Hello students, I am Dr. Tanmoy Biswas. I welcome you all in my YouTube channel TanmoyChem and Facebook page Chemistry the Mystery of Molecules. Today's topic of discussion is on MCQ and the question is in front of you. I request everyone please pause the video, try by yourself and whatever answer you get please write in the comment box along with few words as explanation. I believe you have tried, so let's start. Now, what is the major product of these reactions? This is actually a thioester and this is actually a normal ester. So it's a simple hydrolysis. What will be the product? Before going to the details, let's learn the concept associated with this problem. Sulfur and oxygen both can participate in back bonding with the adjacent carbonyl group, but the carbon sulfur back bonding or double bond, which will obviously happen after this resonance, will be weaker compared to carbon oxygen due to size mismatch. Why? Sulfur belongs to third row and oxygen belongs to second row, and carbon, if you look at it, also belongs to second row. So carbon oxygen energy matching, symmetry matching, size matching, everything possible. That's why this bond is stronger. Next, weaker bond, if you have, for example, carbon sulfur results higher chemical reactivity, means it will participate in chemical reaction very easily. In this case, I would say it will be hydrolyzed very easily. And for neighboring group participation or NGP, the nucleophile and leaving group should be anti to each other. I shall explain during the mechanism. And acetate is actually a good leaving group because the negative charge on O minus is resonance stabilized. So that's why it acts as a good leaving group. Now let's look at what happens. So first step, this OH minus will hydrolyze this part. So what do you get? So this part will be consumed, there will be S minus. Now if you look at this S minus and this acetate part, this oxygen carbon bond is anti, this is top, this is bottom. Now just some time back I told neighboring group participation, nucleophile and leaving group should be anti. Why? Because here the sulfur will donate its electron pair to the sigma star of these carbon oxygen bond. Now obviously if the sigma is in to bottom side, so sigma star will be in top. So that case the similarity or overlap possible, means this sulfur lone pair or electron density can do a overlap with the sigma star of this bond. What will happen? So it will give, so sigma star if accept electron density, this bond will break, or in very easy word, this lone pair will attack here, this bond will break. So what it will result? Obviously a 5-member ring, sulfur 3-member plus acetate. Just some time before I told acetate is a comparatively stable because it is resonance stabilized, because the negative charge is delocalized, means stabilized. So what it will result? This 5-member ring adjacent to sulfur, means a bicyclic compound, the sulfur epoxide type, you may consider it's a thiol derivative of epoxide. So this is, now medium is alkaline. So do not expect that it will be hydrolyzed further so easily, not like that. So this is our answer. So what is the major product of these reaction? So 3-member ring, this is. Now you may ask one question, sir, how can I do this thing if I get this question in the exam? Well, by the way, there is OH minus given, so obviously this bond will break because this bond is the weakest. After that, what is the possible? See, you can say, sir, these hydrolysis is also possible. I agree. But look at one thing, this bond is comparatively stabler, although the negative charge on sulfur, which is not that much stabilized. Why I am saying oxygen is comparatively more electronegative than sulfur. So the negative charge on oxygen is comparatively more stable than sulfur. So this sulfur actually want to do some reaction, and there is a chance this bond is below, this is above. So a nucleophilic attack possible here and it can open up. So 3-member ring formation possible, but sulfur. Now you may say, why not, sir, opposite way? So this bond will break O minus, that will attack, sulfur will leave. See, for that purpose bond strength factor should be discussed. These oxygen carbon bond has more partial double bond character, so you can say, sir, it is stronger and difficult to break compared to this one. So obviously that's why this bond will break. So obviously this is not possible, and in this case, see, this is illogical option. Why? Because they are opposite orientation. Now you can say another thing, sir, OH minus can do a nucleophilic attack, acetate can leave. See, those all things are possible, but first this bond will break. And another thing, this sulfur is attacking here, it is intramolecular reaction. And remember one statement, intramolecular reaction are far more faster or easier due to proper conformational orientation. So that's why compared to all other options, this pathway will be followed so early. So that's why the option D is the right answer. I know it's little easy, but a different type of concept. Read more, practice more, that will be enough. So if you really enjoy, please share among your friends. See you in my next video. Bye bye.